So we're doing number 4 right now, and they want us to find the equation of the normal to the circle x minus 1 squared plus y minus 4 squared is equal to 5 at the point 2, 6. So we did this in class already. So if you need to review it, you could always look at the recordings on Google Classroom. So remember, the first thing you want to do for any question, hold on, you want to write down all the information that they gave you. So they told you that the circle has the equation x minus 1 squared plus y minus 4 squared is equal to 5. They also told us that the normal passes through this point, so I'll just put given point. Is 2, 6. The aim, remember, is to find the equation of the normal. I'll put capital N for normal. That's what the question wants us to find. We know that there's certain steps to follow when trying to find the equation of the normal. So the first thing you want to do is to find the center of the circle. We did this in a previous class already. So if you need to review it, Google Classroom. So what you need to notice is that this equation that they gave us is in standard form. And we know that standard form is x plus h squared plus y plus k squared, that's a plus, k squared is equal to r squared. Remember, the first step, we're trying to identify what the center is. And we already did this in class. To find the center, we know that it has the coordinates minus h and minus k. So what you need to do first, identify h and identify k. We did this already. If you need to review, you know where to go. So I could just look at this, the standard form. So let me just put standard form. Standard. I could just eyeball this, looking at the standard form and then looking at the equation that they gave us. I could identify what h and k is. The standard form says that x plus h squared. That's the first thing it says. And up here we have x minus 1 squared. So x, that's the x here. So that means that h plus h has to be minus 1 in this case. We know that plus h is the same as h, so I could say h is equal to minus 1. Same thing here. We see the y, we see the y. So that means that plus k, which is also k, because if I said plus 5, we know that I'm just talking about 5, right? So k, k would be equal to minus 4. But recall from previous sessions, we said that the center has the coordinates minus h and minus k. Right now, we know the value of h and we know the value of k. So what we need to do is find what minus h and what minus k is. If h is minus 1, that means that minus h would be equal to 1. And if k is minus 4, that means that minus k would be equal to 4. Equal to 4. So that means this is my center now. We said that minus h is 1, so we put 1 there, put your comma, and we said that minus k is 4. So this is my center. And that's the first step finished. The second step is to find the gradient. Remember, gradient can be denoted by m. So I'll put m of r. R is the radius. So let me draw a little sketch here. This is my center. And we now know that it has the coordinates 1, 4. So I'll put the 1, 4. And I'll use purple to represent my given point on the circle. And they told me it was 2, 6. So I'll just put it up here. 2, 6. What we're doing now is trying to find the gradient of the normal, of the radius, my bad. And we know this is the radius. This blue line here is the radius. It connects the center and the circumference of the circle, right? We know to find gradient, we use the formula m is equal to y2 minus y1 over x2 minus x1. That's when given 2 points on a line. So we see this blue line is our radius and we are given 2 points on the line, this red dot and this purple dot. So all you need to do, identify what y1 and y2 is and what x2 and x1 is and substitute it into the formula. So we did this already. If you need to review it, you know what to do. Right, so I want this to be x2, y2. I want this to be x1, y1. But remember, they're interchangeable. So if I wanted to, I could have put this as x1, y2, and this as x1 and y1. So this is equal to y2, 6, minus y1, which is 4, divided by x2 is 2, minus x1 is 1. 6 minus 4 is 2, and 2 minus 1 is 1. So that means the gradient of my radius is 2. So put 2 here. Now is to find out why. Why did we find the gradient of the radius? So let me show you now. Remember, the aim is to find the equation of the normal. And we know that the third step is to find m, which is gradient of the normal. Why do we need to find the gradient of the normal? Because we need it in this form. We know that the general form of a straight line is y is equal to mx plus c. So that's what we want our answer in. So we need to identify what m is, and we need to know what c is. And right now we're trying to find what m is. Let me just do another sketch here. My center is still this red dot. Given point is still the purple. And I'll draw the normal in green. This is what a normal looks like. So a line, you might see it pass through all here. Capital N for normal. You could see, looking at this diagram, and looking at this one, the radius and the normal, they practically look like the same line. If I shorten this line, instead of having that long line for the normal, and I just put it here, it looks like the same thing. The radius looks just like the normal. So that means that the gradient of the radius, we found out that's 2, would be the same as the gradient of the normal. So I need you to remember grad, so that means gradient of r is equal to gradient of n. They look like they're the same line, so they have the same gradient, right? Because gradient is constant. Mhm. So that means that the gradient of n, which is the normal, is also 2. So that's the third step finished. The fourth and final step when trying to find the equation is to find the equation. And we know to find the equation of a line, when given the gradient and a point on the line, we can use these two methods, one of these two methods. So you could use the y is equal to mx plus c method, or you could use the y minus y1 is equal to m in brackets x minus x1 method. I would just use the second one, but you could use whatever you want to. All right? So let me use this. You put back y minus. When you have the normal, you can use either point. Why? Because both of these points lie on the normal. Unlike the tangent, let me draw another thing. This yellow line is the tangent. So unlike the tangent that only passes through this given point, it does not touch the center at all. The only point that lies on this tangent is this purple point. That's a tangent. So I'll put T for tangent. But that's not what we're looking at right now. That's not what we're looking at. We're looking at normal. For the normal, both points lie on the line. So that means I could use either point. So I could use the center, which is 1, 4, or I could use the given point, 2, 6. So looking up down here, the center, 1, 4, or I could use the given point, 2, 6, to find the equation of my normal. Why? Because both points lie on the line. So let me just use the center in this case. So y, my y value is 4, is equal to m. We know m, which is the gradient of the normal, is 2. Put back x minus x1, which is 1. And what we need to do, we need to transpose. Transpose just means to make something the subject of the formula. So we need to make y the subject of the formula. You may be wondering, why do we need to make y the subject of the formula? Because we need it in this form. Y is equal to mx plus c. So y minus 4 is equal to, we could expand these brackets, so 2x minus 2. Therefore, y would be equal to 2x. I have to add 4 on both sides. So minus 2 plus 4, that's plus 2. And that is why this right here is my answer to the equation of the normal. So intersection of a circle with a straight line. That's another thing you have to learn how to do because it's on your syllabus. So you'll come across questions like this in past papers. What you need to do when trying to find the intersection of a circle with a straight line, you need to use the substitution method, right? And we were introduced to this when we were doing straight lines. So you could look back on that if you think you need to. Hold on. Let me just show you what the intersection would look like. Well, might look like. So say I have a circle, a nice big circle. Center is still my red dot. And I have a line. Let me use a blue line. This is my line here. And it passes through. The point of intersection is where the line meets the circle. So we could see here by just eyeballing it that the line meets the circle at 2 points. This point right here and this point right here. And by using the substitution method, we could find out what the exact coordinates of these points are. So remember, coordinates is in the form x, y, x, y. So we could find out what the exact coordinates of these points of intersection are. That's what this whole thing is about. So back to the note. We're using the substitution method to find the intersection. So I have an example here. Find the points of intersection of the circle x squared plus y squared minus 5x minus 5y plus 10 is equal to 0, and the line y is equal to 3x. So the first thing you want to do is to write the equation of the line in the form y is equal to mx plus c. No need to do that because it's already in that form. This is in the form y is equal to mx. But that just means that the plus c would be equal to 0. And if, let me use a quick example. If I had 5 plus 0, nobody writes the answer as 5 plus 0. 5 plus 0, we know that's the same as 5. So there's no need to put the 0. And that's why we just take this off and get y is equal to mx. So just making that clear. So that's the first thing you want to do. Write the equation of the line in the form y is equal to mx plus c. Next step. Sub, which means substitute, the value of y from step 1. So this, the value of y, is what y is equal to. And in this case, y is equal to 3x. So that's the value of y they're referring to. From step 1 into the equation of the circle. What does that mean? Wherever you see y in the equation of the circle, you're going to replace it with the value of y from step 1. In this case, the equation of the circle is x squared plus y squared minus 5x minus 5y plus 10 is equal to 0. So wherever I see y in this equation, so I see y here highlighted in green, and I see another y here, I'm going to replace it with 3x. Why? Because 3x is the value of y that they're referring to. So x squared plus, I see y here, so instead of putting y, I would put 3x squared minus 5x minus 5. I see a y here, so I'll replace it with 3x. This should be green too. So 3x, yeah, plus 10 is equal to 0. Right, plus 10 is equal to 0. And what we need to do now, we need to find what the value of x is. Why are we finding the value of x? Because remember, I showed you the circle, the line, and the point of intersection. We said that this point has a coordinate, and it's in the form x, y. So that means we need to find what x is, and we need to find what y is. This step allows us to find what x is. So just simplify. X squared plus 3x squared, that's 9x squared, minus 5x minus 5 by 3x is minus 15x, plus 10 is equal to 0. I could rearrange this. So x squared plus 9x squared is 10x squared, minus 5x minus 15x, that's minus 20x, plus 10 is equal to 0. I could leave it like this if I want to. Or to simplify this even more, I could say, all right, all of these numbers, 10 minus 20 and 10, they're divisible by 10. So I could divide everything by 10. And what I would get, x squared minus 2x plus 10 is equal to 0. But we're not finished. We need to find what x is. We need to find the value of x. You need to recognize that this is a quadratic, and we did this already. So if you need to review it, you're recording. This slide is there. So there's no recording for that one. Right. So the quadratic, a quadratic is in the form ax squared plus bx plus c. So you need to recognize that this is a quadratic where a, which is the coefficient of x squared, is 1. B, which is the coefficient of x, is -2. And c, which is the constant, is 1. Remember, we need to find the value of x. We need to solve for x. And when we have quadratics, there are 3 ways to solve. Quadratic formula, factorization, or completing the square. Usually, nobody usually uses the completing the square method unless they ask you to do that. You could use the formula if you want to, or you could use factorization, the factorization method. But not all quadratics could factorize, only some of them. So if they can't factorize, you'll most likely go to the quadratic formula instead. But this one here could factorize. And if you need to review what factorization is, just look at the slide named Quadratics 1. So remember, when factorizing, so say I have two numbers, D and E, what factorization is? It says that I need to find two numbers, so my two numbers D and E, that when added, so D plus E would give me the value of B, would equal to B. Let me just write what the quadratic looks like. Ax squared plus bx plus c. So two numbers, when added, would give me this value of B. And when they are multiplied, so D multiplied by E would give me the same value as if I multiplied A times C. In this case, my two numbers would be -1 and -1. -1, let me show that to you real quick. So remember, we need two numbers that when added will give me the value of B, but when multiplied will give me the value of A multiplied by C. So in this case, I said it's the two numbers we're looking for is -1 and -1. So let me show you. -1 plus -1, we need that to equal to the value of B, which in this case is -2. -1 plus or minus is a minus, so this becomes -1 -1, which is equal to -2. So we go with that. But the rule also says that these two numbers, so -1 and -1, when multiplied, need to give me the same value as if I multiplied A by C. A in this case is 1 and C is 1. So 1 times 1 is 1. And we know that -1 times -1, a minus and a minus is a plus. So 1 is equal to 1. Right, so we know that works. When you factorize that, you'll get the two factors. Both of them would be equal to x minus 1. So you use that to solve for x. And how do you solve for x? You put each factor equal to 0. So since the factor is x minus 1, and x minus 1 is equal to 0, when solving by factorization, you put the factor equal to 0, and you solve for x. So x would be equal to 1. No need to do it 2 times because it's the same thing. So therefore, x is equal to 1. Third and final step. Which means substitute the value of x from step 2 into the equation of the line. So we know the value of x that they're referring to is 1. We found out that x is equal to 1. And what we need to do is substitute that into the equation of the line. What do I mean by this step? Wherever you see x in the first equation, which is the equation of the line, replace it with the x value from step 2. So they told us that the equation of the line is y is equal to 3x. Wherever I see x, instead of putting mark x, I would replace it with 1. So this becomes y is equal to 3. Instead of putting x, I put 1. And we know that 3 times 1 is 3. And therefore, the line intersects the circle at the point 1, 3, where 1 is my x value, 3 is my y value. This is what that would look like. So you have a circle once again. And I said that this point up here is 1, 3. That's the point of intersection we just found. That's where the line would intersect the circle. So where the line and the circle meets is at the point 1, 3. And notice this is a tangent. Why is it a tangent? Because we know that tangents are lines that touch the circle only once. And just like this line, it touches the circle only once. So we can say that it's a tangent. This is the question we're doing now. It's paper 2, 2017, number 3, A part I. Right? And what they want us to do is determine the point of intersection of the circle and the equation y is equal to 4 minus x. Clear on my drawings. Teacher. Similar question. They want to know where the circle or the line of the circle intersect. They told us that this is the equation of the circle. So let's go back. This is the question we're doing. So first write down all the information that they gave you. They told us that the equation of the circle is x squared plus y squared. Am I recording? Yes. X squared plus no. Okay, x squared plus y squared. Okay, I don't know what that is. Plus 4x minus 2y minus 20 is equal to 0. That's the equation of the circle. And it told us that it has a line with the equation 4 minus x that intersects the circle. And what they want us to do is to find the points of intersection. So point or points, you never know if it will be 2 or more, of I'll just put intersection. The first thing you want to do, remember, is to put it in the form. Put what in the form? Put the equation of the line in the form y is equal to mx plus c. You could leave this right here. You could leave it as y is equal to 4 minus x, or you could follow what the first step is, what the first step says, and write it in the form y is equal to minus x plus 4. But it doesn't matter in this case, right? You just want y is equal to something. So the first step is finished. The second step says that you want to substitute. So put sub value of y into circle. What do you mean by value of y? Whatever y is equal to. So in this case, it's 4 minus x. So looking at our equation of the circle, wherever we see y, we're going to replace it with 4 minus x. So x squared plus, instead of y, I would put 4 minus x squared plus 4x minus 2. Instead of y, I put in 4 minus x. Just continue down here, minus 20 is equal to 0. Remember, the aim of this, the purpose of this step is to help us find our x value for the coordinate. So we need to simplify and we need to solve for x. I told you about a rule in the previous class. So what this rule states is that a minus b squared is equal to a squared minus 2ab plus b squared. This is not something that you just have to do when you have to learn when you're doing circles alone. You'll probably, no, not probably, you will come across something like this in odd math, in regular math, in any type of math. So this is good to know. Or you could just use the distributive law that you learned in school. So 4 minus x squared is the same as 4 minus x multiplied by 4 minus x. And just use the distributive law to find out what that is. So 4 times 4, then 4 times minus x. Yeah. When instead of doing all that, you could just follow the rule in purple. So this becomes x squared. Let me use a different color. Yeah. So this becomes x squared plus 4 minus x squared. According to this rule, a would be 4, b would be x. And according to this rule, the first thing I want to write is a squared. If a is 4, I write in 4 squared, which is 16, minus 2ab. So a, which is 4, and b, which is x. A by b would be 4x. So minus 2 by 4x, that's minus 8x. Then it says plus b squared. B is x, so I'll put plus x squared. And you continue that for x. Distributive law. Minus 2 times 4, that's minus 8. Minus 2 times minus x. A minus and a minus is a plus, so that's plus 2x. Minus 20 is equal to 0. I could simplify this even more. Group all the like terms together. So let me use blue. I'll cross out as I go along. So x squared plus x squared, that's 2x squared. Minus 8x plus 4x, that's minus 4x. And minus 4x plus 2x, that's minus 2x. 16 minus 8, that's 8. And 8 minus 20, that's minus 12. And all of that is still equal to 0. So like I said before, you could leave this as it is and solve for x, or you could recognize, okay, all of these will be divisible by 2. So I could factor out the 2 and get x squared minus x minus 6 is equal to 0. We're not finished here. We still need to find what the value of x is. So now we could say that our quadratic is, I need to use a different color, is x squared minus x minus 6 is equal to 0. Now we still need to solve what x is. So remember the 3 ways of solving the formula, factorization, or completing the square. Most people lean towards factorization, But remember, not all quadratics could factorize. So then the next option most likely would be the formula. This particular quadratic could factorize. So it becomes x squared. The two numbers in this case would be minus 3x plus 2x minus 6 is equal to 0. Remember, when factorizing, we need to find two numbers that when added would give me b. b in this case is minus 1. And minus 3 plus 2, that's minus 1. But we also need to make sure that when I take these two numbers and multiply them together, the answer would be a. So the coefficient of a, which in this case would be 1, times c, which is minus 6. Minus 3 times 2, that's minus 6. And 1 times minus 6, that's minus 6. So we know we could. When I factorize this, remember, I'm going a little fast because we did this already. If you need to review it, Google Classroom. All right. So when I factorize this, the two factors I will get is x minus 3, x plus 2. And this is equal to 0. We know that when solving by factorization, we need to set each factor equal to 0. So put each factor equal to 0. X minus 3 is one factor, so I put that equal to 0. X plus 2 is the other factor, and I put that equal to 0. And I solve for x. If x is minus 3, no, if x minus 3 is equal to 0, that means that x has to be equal to 3. And if x plus 2 is equal to 0, x has to be equal to minus 2. Notice that unlike the example that had only one value of x, this question has two values of x. So what does that mean? I have 2 points of intersection. This is what it might look like. I circle on my line, 1 point of intersection, another point of intersection. Unlike the example which looked like this. Circle, line, with 1 point of intersection. So this is what the example looked like, but this is what this question might look like. 2 points, this is 1 point. And how do we know we have 2 points of intersection? Because we have two x values. Recall coordinates in the form xy. I'll just put prime here. We have two values of x. X is equal to 3, and we have an x is equal to minus 2. So that means we would have two different coordinates. Just to make that clear. So now that we know x is equal to 3 and x is equal to minus 2, x is equal to 3, x is equal to minus 2, we need to use these values to find out what y is. The third and final step is to substitute. So sub means substitute. Value, in this case, is values of x into the equation of the line. So just put into line. We know that the line is y is equal, let me erase. We know that the line is this, has this equation, y is equal to 4 minus x. So what we're doing now, wherever we see x in this equation, we're going to substitute it with 3, and then we would substitute it with 2. So y is equal to 4 minus, so I'll put an x in this case, I'll put 3, which is equal to 1. So what does that mean? When x is equal to 3, y would be equal to 1. And my coordinate for that would be 3, 1. But you can't just leave out this one. You can't do that. You also need to find what the other coordinate is. So doing the same thing. Y is equal to 4 minus, instead of putting x in this case, we're going to put minus 2. So that's minus minus 2. We know that a minus and a minus is a plus. So 4 plus 2 is equal to 6. What does that tell us? When x is equal to minus 2, y is equal to 6. And that's why our second coordinate is minus 2, 6. And these would be this and this. Those are my answers for the coordinates of the points of intersection.